Aloha, and welcome back to Maui Huliau Foundation's Climate Literacy Virtual Classroom. In Unit 1, you learned how CO2 and other greenhouse gases enter our atmosphere and how it impacts our planet's climate. In Unit 2, we're going to be focusing on the impacts of climate change, from melting ice and sea level rise to ocean impacts and extreme weather events. We'll start off in Part 1, learning about the impacts of melting ice and sea level rise threats. As we learned in Unit 1, climate change is caused by the increase of CO2 and other greenhouse gases entering our atmosphere, with the burning of fossil fuels being the leading cause. These extra greenhouse gases are causing the planet to warm. Earth has already warmed around 1.8 degrees Fahrenheit on average, and this trend is expected to continue. While Earth's average temperature is getting warmer, not all places on Earth are getting warmer at the same rate. In fact, as you can see here, the few blue spots indicate places on Earth that have actually cooled slightly. The darker red areas indicate where the most warming has taken place. As you might have noticed, the polar regions, especially in the north, have warmed the most. As we explained in Unit 1, global warming refers to the average warming of the planet, while climate change refers to changes that happen in Earth's climate systems as Earth gets warmer. In this part, we'll be exploring a few of these changes caused by Earth's warming, the melting of land and sea ice, and the impacts on sea level rise. As we mentioned, the polar regions are warming faster, and this is where much of the Earth's ice is located. Antarctica, in the southern polar region, is an icy continent containing the largest amount of land ice on the planet, and it is also surrounded by sea ice. The Arctic is located in the northern polar region and consists of sea ice, almost completely surrounded by land. The Greenland ice sheet is an example of land ice, as it sits on top of Greenland, the largest island in the world. So what is the difference between land ice and sea ice? Let's take a closer look. The Arctic consists of sea ice, which frozen ocean water forms in the winter months and partially melts in the summer. Here you can see the sea ice and land ice that make up the Arctic. However, as the Earth gets warmer, more sea ice is melting each summer, and not as much is freezing each winter, resulting in an overall loss of sea ice, especially in the Arctic. Melting sea ice is a problem because it creates something called a positive feedback loop. Sea ice is extremely reflective or has a high albedo. When sunlight hits the ice, it reflects up to 90% back into space. As the sea ice melts in the summer, instead of sunlight being reflected by the ice, the majority is absorbed by the ocean. As you can see here, the ocean water is much darker than the sea ice, and therefore absorbs more light, rather than reflecting it. This extra heat from the sun warms the ocean and causes even more sea ice to melt. This is an example of a positive feedback loop, because the result of the sea ice melting leads to even more melting. Now let's take a closer look at land ice. As you can see from this map, in addition to the largest land ice sheets in Greenland and Antarctica, land ice also exists around the world in places where snow that falls in the winter does not melt entirely over the summer, such as in high elevation mountain areas. Like sea ice, land ice is also melting more each summer as the Earth gets warmer. An example here, Muir Glacier in 1941 compared to 2004 shows a drastic decrease in the size of this glacier. So how does the loss of land ice impact sea level? When a glacier or ice sheet melts, the fresh water in them is released and eventually travels to the ocean. Therefore, ice melting on land contributes to sea level rise by adding water to the ocean. Sea ice, on the other hand, is floating frozen seawater and does not impact sea level rise when it melts. Think about a glass of water with ice cubes. The ice cubes are like the sea ice. When the ice cubes melt, does the water overflow? It doesn't, and that's because the water created by the melted ice just fills the space where the ice cubes were before they melted. But if the ice cubes are outside of the glass, and when you pour the melt water into the glass, it will overflow. This is similar to how glaciers and ice sheets melting on land add extra water to the ocean. For this reason, it is melting land ice that causes sea level to rise. So sea level is rising primarily due to melting land ice. However, the ocean getting warmer is also causing sea level to rise. As water gets warmer, it expands, and the volume of the water increases. This is called thermal expansion. So meltwater and thermal expansion greatly impact global sea level rise. Scientists study global sea level using tide gauges and satellites. From these readings, they can document sea level changes and monitor trends. Since we began burning fossil fuels around 1880, global sea level has risen around 8 inches. Projections have been made for global sea level rise to the year 2100. On the low end, we might experience a 7-inch additional increase, but worst case scenario, we predict up to a 6.6 feet increase in sea level, with some regions experiencing even higher sea levels. Due to the many complex factors such as wind and ocean currents, latitude, and the uneven gravity field on Earth, sea level is predicted to rise more in some locations than in others. Areas which are already very close to sea level are particularly vulnerable to sea level rise. This includes low-lying islands in the South Pacific like Kiribati, Tuvalu, and the Marshall Islands, which lack the high mountains that we have in Hawaii. There are also many coastal cities with large populations which are close to sea level, such as Miami pictured here and many cities in Southeast Asia. In Hawaii, we're already seeing the impacts of sea level rise. Honolulu's shoreline, specifically Waikiki, have been experiencing a reduction in shoreline. One thing to note is that sea level rise does not just affect shorelines. Honolulu is already seeing sunny day flooding during high tides. This is when ocean water comes up through the storm drains in low-lying areas of the city that are further inland during a high tide due to the increase in sea level. On Maui, the road to Lahaina near Olowalu has more frequently been experiencing flooding, and the shorelines are disappearing. This map of Kihei, under a 4-foot increase of sea level, projects new wetlands appearing and extensive flooding to this low-lying area. We'll dive deeper into sea level rise in Hawaii in one of the activities. Let's take a look at the activities for this part. In the first activity, global warming and melting ice, you will learn about the causes and effect of melting ice. The second activity, measuring the melt, will look at specific polar regions and analyze data on sea and land ice loss. The last activity will focus on sea level rise in Hawaii and how melting polar ice causes an increase in sea level rise. Once you complete the activities, take Part 1 quiz. Additional video resources are available for more information on the topics covered in this part.